Hi, this is Lab 5. Choose your own adventure. In this course, we so far study the basic fundamental principle, that is the Newton's second law of motion and momentum principle. For Lab 5, I choose paper plane as my system, and the fundamental principle I use in is the Newton's second law of motion and the momentum principle. The Newton's second law of motion is that final velocity is equal to initial velocity plus f net over mass times delta t, and the momentum principle is a delta p equal to f net times delta t. In this lab, two forces are acting on my system, that is the weight force and the drag force. The weight force is equal to mass times acceleration due to gravity, and the drag force is equal to b times velocity of the object. The b is a constant terms, and its value is equal to 6 pi h rv, and the total force on our system F net is equal to the weight force plus the drag force. We perform an experiment on a paper plane. By using tracker, we collect a motion data. On the left corner, we see the position of the paper plane in y-axis, and here we see the position of the paper plane in the x-axis. The total station is the 0.7 second. I copy all these position data values and paste it in the Google spreadsheet. Here in this graph, the gray line shows the position of the paper plane in y-axis, and here the white line shows the position of the paper plane in the x-axis, which is in positive direction, and here its value is in the negative direction. From these values in tracker, I calculate the initial position, which is equal to 0.09 and minus 0.03, 0. Initial velocity 3.43 in x-axis and minus 1 in the y-axis. The mass of the paper bar, which is equal to 4.5 gram, which is equal to 0.005 kg, and the total station is 0.7 second. By using VPython, I construct a computational model. Here is the paper ball, paper mass, the position data, the initial velocity, the acceleration due to gravity 9.8, the v constant 0.0035, the total time 0.7, weight force is equal to the minus paper plane mass times g times j hat, and the drag force equal to minus b paper plane velocity. The F net is equal to the weight force plus the drag force. Here is the Newton's second law of motion, and from this equation we can calculate the future position of the object. When we run the module, we will see that the object will move in exactly the same manner as here shows. By using the Google spreadsheet, I construct a graph between model versus experiment. The blue curve shows the experimental position, and the red line shows the model position. Here we can see that they are exactly in the same line. So here it is the value of the F net, here is the value of the weight force, here it is the value of the drag force. When we add these two, we can get the F net. This is the end of the lab 5. Thank you.